Hello, in this video we're going to look at the basics of trigonometry. Trigonometry deals with measurements of triangles, specifically relations between sides and angles. It is described by three principal functions that we will use heavily: sine, cosine, and tangent. These are abbreviated sine m, cos m, and tan m. Now I referred to them as functions. I've written sine m, cos m, tan m. These will always be the sine of something, the cosine of something, the tangent of something. Here, m represents one of the acute angles of a right triangle or its measure. So of course, I won't always say sine of m or sine m. It could be sine x or some other angle of some other acute angle in a right triangle. Or I could say sine, cosine, or tangent of a degree measure, such as tangent 72 degrees. But for our purposes, we will only be doing these for acute angles, which is strictly between 0 and 90. What do these functions mean? Well, each of sine, cosine, and tangent represent a specific ratio between sides of a right triangle. If I wish to understand that, well, I need to first look at a right triangle. So here I see triangle ABC. The sides are labeled. I want to first pick an acute angle. I can look from either angle A or angle B as my acute angle. I'll start with angle A. So if I'm looking from angle A, it helps to just mark that that's where I'm looking from. So I've marked the angle. Now, what I want to do is label the sides of this triangle. I will label them the hypotenuse, opposite leg, and adjacent leg. Does not matter if I'm looking from angle A or angle B. The hypotenuse of a right triangle is always in one particular place, that is, across from the right angle. So C is our hypotenuse. The other terms I just mentioned, the opposite leg and adjacent leg, well, we know that opposite means across from, we know adjacent means next to. So again, if I'm looking from angle A, the opposite leg is right over here, little a. If I'm looking from angle A, the adjacent leg is little b. So again, this is where it's very important to have marked whatever angle I'm looking from. If I was looking from angle B, then I would have switched the opposite and adjacent. As it is, I am looking from angle A, so I have labeled the triangle to help me in the next step of this. So I want the sine of A, the cosine of A, and the tangent of A. Well, each of these represent a particular ratio in the triangle. Sine refers to the ratio of the opposite leg to the hypotenuse, cosine is the adjacent leg to the hypotenuse, and tangent is the ratio of the opposite leg to the adjacent leg. I was asked specifically for A, so I'm looking at this triangle, and I can describe this using these sides. So the sine of A. Sine is opposite over hypotenuse, the opposite leg over the hypotenuse. So here, that is A over C. The cosine is the adjacent leg over the hypotenuse. So the adjacent leg is B, the hypotenuse is C, so I will write B over C for cosine. The tangent of A refers to the opposite leg over the adjacent leg. Again, coming back up here to my diagram, I can see I've labeled the opposite leg and the adjacent leg A and B. So the tangent of A is A over B. It's a relatively simple process once you've picked your angle, and if you've labeled correctly, you should be fine. Now, you will have to do this repeatedly, so we need some way of remembering that sine refers to the opposite leg over the hypotenuse. Cosine refers to the adjacent leg over the hypotenuse. Tangent is opposite leg over adjacent leg. So, the little acronym that we will use is SOHCAHTOA. This is a simple little acronym. All that it's telling us is that sine is the opposite leg over the hypotenuse. Cosine is the adjacent leg over the hypotenuse. And tangent is the opposite leg over the adjacent leg. That is all that SOHCAHTOA is trying to tell us. It's very useful, as we will have to set up these ratios many times over when we are using trig. So I advise you to commit this to memory, because you don't really have much of a choice on that one. Let's continue. Here I see another triangle. I'm asked to find the sine, cosine, and tangent for both acute angles of triangle PQR. I have two acute angles. They are P and R. Q right there is right. The sides have been labeled now with numbers, 7, 24, and 25, which do make a right triangle. So first, I'm going to pick one of the angles to do first. I will start with angle P. So if I start with angle P, I will find the sine of P, I will find the cosine of P, and the tangent of P. Now I know that if I'm using trig, I must label the triangle. Looking from P, I know that 25 represents the hypotenuse. Opposite angle P is this segment right here, which is 24 units long. And adjacent to angle P is this segment right here, which is 7 units long. So now, when I'm doing the sine of P, the cosine of P, the tangent of P, again, I need to remind myself that the sine is the ratio between what two sides. So I will write SOHCAHTOA. You can write this as many times as you want. You can write it once per problem if that's what makes sense to you. Because again, you have to be able to set up these ratios. So the sine is the opposite leg over the hypotenuse. That's what we're told up here. That's what SOHCAHTOA is telling us. So for this triangle, that is 24 over 25 if I'm looking from P. Cosine of P is adjacent leg over the hypotenuse. Adjacent to P is 7, the hypotenuse is 25. And the tangent of P is the opposite leg over the adjacent leg. The opposite leg is 24, the adjacent leg is 7, so this is 24 over 7. Alright, at that point, I have found the sine, cosine, and tangent of angle P. But I do have another acute angle in this triangle. That is angle R. So I will also need to find the sine of R, the cosine of R, and the tangent of R. So I could scratch these out and relabel this with respect to R, looking from R, which is the opposite leg, which is the adjacent leg. I could do that. It's ultimately probably going to be a little bit easier to just make a quick little re-sketch of the triangle. P, Q, R, 7, 24, 25. Now again, I know I want to find these three trig functions with respect to R. If I'm looking from R, then I know that 25 is my hypotenuse. The opposite leg is 7, and the adjacent leg is 24. When you're labeling these, be careful. If you do label them incorrectly, then in all likelihood you will not get the answer correct. But you have to be careful here. Always label the hypotenuse first, then it's a bit easier to pick between the opposite leg and adjacent leg. So, if I'm looking from R, the sine of R, sine again means the opposite leg over the hypotenuse. So if I'm looking from R, the opposite leg is 7, the hypotenuse is 25. The cosine of R, cosine is adjacent over hypotenuse. The adjacent leg is 24, the hypotenuse is 25. The tangent of angle R. Well, tangent again refers to the opposite leg over the adjacent leg. Opposite angle R is 7, adjacent is 24. So I have now 7 and 24. I found the sine, cosine, and tangent for both of the acute angles of this triangle. Now, you will notice, and this should make sense, the sine of P is 24 over 25, the cosine of P is 7 over 25, the tangent of P is 24 over 7. If I compare these to the sine, cosine, and tangent of angle R, angle P's complement in the same triangle, now I see that the sine of P is the cosine of R, the cosine of P is the sine of R, and the tangent of P and the tangent of R are reciprocals of one another. Again, this should make sense because the only difference when I'm looking from P or from R is which leg is opposite and which leg is adjacent. Again, this is a very useful piece of information. But what's more, the fact that I know that the sine of P is 24 over 25, the fact that the cosine of P is 7 over 25, the tangent of P is 24 over 7, that itself will be useful. Here are some useful facts about trig functions, and this will be the basis of what we use trig for. If angles A and B are complementary, which again means their sum is 90, then the sine of A is the cosine of B. Additionally, the tangent of A will be the reciprocal of the tangent of B. These are useful facts. They can come up sometimes. It's more worth to point them out than something to be remembered. Now, second most useful fact, more useful than the first one actually, two acute angles have the same sine, cosine, or tangent ratios if and only if they are congruent. So, that means if I have a right triangle with some particular angle measure, then I know that the sine will always be in some particular ratio, whatever number that might be. For example, if I said the sine of 55 degrees, I can determine that that will always be approximately 0.8192. Similarly, if I go in the opposite direction, if I wanted an angle with a tangent of 10 over 13, there is only one angle that will allow me to do that. It is unique. This is why trig is so useful to us. This will allow us to solve for missing sides, to find unknown angles, because our calculators know how to determine these things.